All right, kids. So in this extension section, remember this is in your book. This is after the review section, I believe, at the very end of chapter 7. You're asked to draw a general quadrilateral. Just pick. What we're going to do is going to work for any quadrilateral that you'd ever pick. But, to be consistent, let's go ahead and use the same thing, okay? So in red, just pick the same points that I'm going to use. That way we're kind of talking the same language, and it works out somewhat nicely too. So -1, 2, 6, okay? And we'll go with -5, 1, 2, 3, 4, 5, -5, 0, 3, 4, and we have 5, -6. So we have a quadrilateral. And it's just a quadrilateral. It looks like it might be a trapezoid, doesn't it, on its side, but I don't think it is. If we did the slope here, 6 minus 4 is 2. -1 minus 3 would be -1/2. Would be that slope, and then this is not going to be -1/2 if you do that calculation. So it's just a generic quadrilateral. Now it says connect the midpoints and discover what you can about the new quadrilateral. So what we'll do is we'll do this in blue. So the midpoints, sorry, might be a little bit sloppy, but if you did midpoint formula, would confirm it. This would be 1, 5. This would be -3, 3. You'd have 0, -3. And you'd have 4. Again, I mean, if you did it with midpoint formula, you'd confirm it. And then we would end up with a new quadrilateral, ABCD. Now, what do we discover here? Part of it's coincidence, part of it's not. So let's look at the slope of AB. So AB, you get a slope of 2/4, which is 1/2. Let's look at the opposite. So that would be CD, slope of CD. That would be 2/4, so 1/2. Okay, I'm going to look at slope of BC. That would be 6 over -3 or -2. I'm going to look at the slope of AD, which is -6 over 3, -2 as well. So we have we have parallel, right? So we have a parallelogram. Now, the part that's not coincidence, this will always happen, okay? Whenever you connect the midpoints of any quadrilateral, the new quadrilateral that you form in the middle will always be at least a parallelogram, okay? Will always happen. Connecting midpoints of any random quad will give you a p-gram inside, okay? Now, What is coincidence is that these are opposite reciprocal slopes. That's just coincidence that I picked something that ended up being a rectangle in the middle. Okay? It is just coincidence with this problem that you get a rectangle. All right? So you could get a rectangle, you could even get a square, but you will always get at least a parallelogram. Now, I'm going to talk about why that happens. It's due to something called midline theorem. Check this out. I'm going to throw a lot at you here. So if we had a triangle, and I know my triangle looks isosceles, but it doesn't have to be. Here, I'll draw it more. Okay? And we found the midpoint of two of the sides. Okay? What the midline theorem states is the segment connecting these two midpoints, remember those were given as midpoints. That dashed segment is always going to be half this third side of the triangle in parallel. Okay? Segment connecting two midpoints of triangles' sides will be parallel to third side of triangle and half its length. Now, let me show you why. All right? Why is this going to be parallel and half the length of that? Now, I hope you guys agree that with any triangle, you know, if we were to do some constructions, we could take out a ruler and a compass. We could go ahead and, you know, take this segment here, take this segment and copy it over here, just extend it. And we're going to, so this is the same exact length as that. Okay? And that looks like it's a little bit too long. Let me fix that a little bit. But so this is congruent to that by design. We're just measuring that and slapping it on here. All right? Now, I'm going to connect this to create a triangle here. Now, what I hope that you see is that these two triangles, this one, those two triangles there, this will come back. These two triangles are going to be congruent by SAS because you have vertical angles and you got side angle side. So if these two triangles are congruent, that means that this side here has to be congruent to that side. And of course, by transitive, this side would be congruent to that. All right? So you see here, we just formed a, you know, a parallelogram, right? We just formed a parallelogram. And I'm just checking some other stuff out because remember, not only do we get this side congruent to this side, but we also have this angle congruent to this angle. And that forces this to be parallel to that, you see? So we have one pair of opposite sides, both congruent and parallel. So this whole thing's a parallelogram. Well, we know that the opposite sides of a parallelogram are congruent, so we've already taken care of this parallel part. And then we know that the opposite sides of a parallelogram are congruent. Well, if this whole side of the parallelogram has been cut in half, so this must be half of that. Okay? Now some of you might be saying, now how does that help in this problem that we just did? Well, take a look here. Okay? Picture this. Remember, these were midpoints, this and this. So if I drew in this diagonal of my original red quadrilateral, I created a triangle up here, you see? In connecting these midpoints of these sides, that means this blue segment is half this length and parallel to it. But you see, I have a triangle here as well, and these are midpoints as well. So this must be half this length and parallel to it. So these two opposite sides are congruent and parallel, right? Now, I have the same thing. Look at this. See, look, I created a triangle here. These are midpoints. So that means this side has to be parallel to this and half its length. And I have a triangle here as well. Okay? So I'm throwing a lot at you. Midline theorem's kind of cool. All right? But the bottom line is two things here. The segment connecting the midpoints of two sides of a triangle will always be half the length of the third side and parallel to it. And whenever you connect the midpoints of a any quadrilateral, when you connect those midpoints, you will always form at least a parallelogram. Okay? All right. Now, I'm going to do this last one here. I'm not going to sketch this out. You can sketch it. I'm just going to save a little bit of time. But again, most of the time you want to emphasize slope. Okay, you can sketch out right now here. The slope is of AB is going to be negative 1/5. And then the opposite side is going to be DC. That also has a slope of negative 1/5. The slope of BC is going to be negative 5. And the slope of AD is going to be negative 5 as well. Okay. Now, what do we got here? Well, both pairs of opposite sides are parallel, so you have a parallelogram. Okay, remember, we're not connecting the midpoints here. This isn't asking us for that. We also know that remember, these are not opposite reciprocals, so we don't have a rectangle. We don't have a rectangle. Let's take a look at the slopes of the diagonals. And these diagonals are perpendicular. So that means you have a rhombus. If you have a parallelogram with perpendicular diagonals, because remember, parallelogram, the diagonals bisect each other. And if they're perpendicular, it means they're perpendicular bisectors of each other, which gives you a rhombus. Now, you can't stop there, okay? You can't stop there. You have to go further and explore whether or not it's a square. I don't know if it is a square. Let's check it out. Well, actually, we already know it's not a square, right? But we should explain that. It's not a square or a rectangle as consecutive sides are not perpendicular. So that means our answer is rhombus. But don't just stop there. Say why it's not the next thing. Okay?